Here is Adam.
Hello, hello. All right, thank you. I am Adam, like Jesse said. Props to Jesse. He gave me a big bag of swag here to give out. I have a few interactive parts. If you can answer a question, I'll throw you a T-shirt. If it's the wrong size, come on up afterward and see what's in the box. I know it. All right, are they all extra large? All right, GraphQL. First of all, some housekeeping. If you want to see these slides later, if there's something that I move a little too quick on, you want to take a closer look, they're all up on my repo. You can clone that, npm init, npm start, and then you can run these on your own computer at home. Some prior art. Anybody here to see Jesse's talk last October, I believe, on Apollo and GraphQL? It was really cool. If you haven't, check out these slides. It's almost like the prequel to this talk. He had a video game theme, which was really, really cool, and I just watched these slides yesterday when I found this link. And it kind of fits well. Like if you think of GraphQL like a video game, that long introductory cutscene would kind of be his talk. And then once the cutscene's over and you're dropped in the game and you're trying to figure out what in the world you're doing, that's what I'm going to try and go over, hopefully. All right, so here's your first T-shirt opportunity. This isn't a joke, it's a serious question. Who can tell me what these things have in common? Web components, service workers, or GraphQL? Anybody have a guess on that? Jesse. Yeah, I'll take it. Here, Jesse, have a T-shirt. What he said's true. I was looking for primitives. They're all primitives. They're all very low-level things that are useful. They tend to possibly be inconvenient to use directly, but you can build on them pretty easily. So like service workers, if you are looking to just have a line or two of config and have a service worker cache and update some files, you're going to have a bad time with it. You're going to want to use something like Google's Workbox or SW Precache. Same with web components. You're not going to want to use it directly. You'll want to use something like Polymer or Skate. So it is kind of with GraphQL, although that's a lot easier to use directly, and that's what we'll go over. So why GraphQL? What's the point? What does it do for us? It gives us a type system for queries. What does that mean? I'll kind of show you. It gives you a query language. Of course, you need some sort of language to make your queries. It supports nested and graph-like data. That's sort of the big one. Graph-like nested data is a first-class citizen with GraphQL, and I'll go over what that means. So you've got this big object graph in your GraphQL endpoint, and you can just tell it what you need. And here's a quote from Jesse's slides. You have one really smart endpoint instead of many dumb endpoints. So with REST, oftentimes you need to have lots and lots, or even without REST, if you just have your own data layer, every little operation and use case, it's probably going to have its own endpoint. GraphQL gives us the opportunity finally to eliminate all those and just have one smart endpoint. All right, let's explore how we would go about implementing this. Please don't get overwhelmed with these slides. It's a tough balance to strike. If I show you too little code, it starts to not be too useful. If I show you too much code, it can be overwhelming. So I tried to thread that needle as well as I could. We're not going to stress on every semicolon and every brace. Just try to look for the high-level concepts and what the point is. So, okay, let's dive in. The first thing you're going to need for a GraphQL endpoint, you're going to need a schema. You're going to need to tell GraphQL what your pieces are. So you can declare types, like here's a book type. And it's got some properties on it. Unfortunately, I made them all strings, which I see now. I wish I had done better on that. It also supports integers, floats, booleans, and of course, other types. You can have, like I said, nested data. And also part of that schema, you're going to declare what your queries are. This query here, that's sort of a reserved word with GraphQL. That query is going to, underneath that, you're going to declare what all your queries are. So here's an all books query, and it returns this intermediate type up here. And that type has an array of books on it. So in real life, you could just have the return type of the query be an array of your type. That's fine, that'll work. I just wanted to show this to you. There's another reason I wanted to show that to you that'll be evident in a minute. But in real life, you'd have other things here, like maybe some metadata on how long your query took. You might want to have aggregation numbers like, hey, just run this query, but just tell me how many there were, and so on. And these queries can also have arguments if you want. So instead of just the name here, you can throw some parens on there, and your query now takes some arguments. What does it look like when you run the query. So I showed you how to declare them. Here's what it looks like when you run it. So that right there is a whole query that you're running that I just showed you. So you start with the name of the query, and then you tell GraphQL what you want back. Remember on that slide before I said that you just pick what you want, you tell GraphQL what you want? Well, that's how you do it. So this guy has an object on it called books, and each book is of that type. So we're saying, hey, I want the books back, and within each book, give me the ID and the title only. And if your query has arguments, that's how you pass them. And remember I said nested data is a first-class citizen. Well, if any of your results have results inside of them, you just keep on nesting them in. So our blog, I didn't show you a blog type, but it would likely have a title and a content. It may have an author object that has a name on it, and we can just nest as deeply as we needed. We may have comments on the blog, and the comments may have moderators, each moderator, and so on. You get the point. You walk that object graph as deeply as you want, and you just tell GraphQL whatever you need. The slide's a little scary. Don't let it overwhelm you. This is just the boilerplate, just to show you how straightforward it is. This is your Express boilerplate. Say, hey, Express, I want to create a GraphQL endpoint. This is the address, and I'm not going to go over every line of this, but that's just how you get it set up. This is the schema I showed you before. The resolvers are what the next many slides are going to look into. This root will become relevant in a little while, but just some basic boilerplate. And once you do that, here's one of the coolest parts. You get a sandbox built in out of the box for you for free. And it's called GraphQL. See the I there? That's GraphQL. And that was this little guy here. Once you pass true for that, now you've got a sandbox. You can just come in here. You can just hack away and test your queries. Say, hey, I want to run that, and here's the fields I want, and it'll execute it, and it'll give you the results right in line, or it'll give you errors. It's pretty neat. All right, so let's dive in now. How do we get that query working? If you're thinking, well, I'm just going to give it an address to my Mongo database, and it'll just figure it out. No, it's a primitive. You have to do it yourself. You have to tell it everything to do, everything on how to load every one of your types. And that's what we'll go into now. And this is the part where I hope I don't show too much code. I hope it's not confusing. I just want to give a sort of a high-level introduction to what this might look like. So that query before, here's how we implement it in the resolver. So this query here, we're going to have a query object on our resolver, and then the name matches up, and this is my opportunity to implement it. And GraphQL will call this for me. When I run this query, GraphQL will call this method, and it's going to pass me my root before. I'm going to go into what those arguments are later, and then you just do it yourself. And the query is called all books, so I'm just dumping my books collection down there. So this doesn't look all that useful or interesting or happy right now. It looks like it's a lot of work for nothing. So let's dive in a little more deeply and see how it looks in a minute. Let's update that query to be a little more useful. We don't want to just dump our whole table. Let's add a title filter. Let's say, hey, I don't want all books. I want all books that just match this title filter. Well, okay, this is Mongo. If you're using T-SQL or Postgres, whatever, it'll look a little different. But for Mongo, it's JavaScript-based, so I'm going to have a filters object. And when I run my find in Mongo, or I might use aggregate in real life probably, I'll pass my filters object, and I just sniff out, see if they passed the title. If they did, I'll filter it on that. That's still not too realistic. Let's say, well, I don't just want to match an exact title. I want to say, hey, if a title contains this string anywhere, or starts with it, or ends with it, and it's just getting uglier and uglier and uglier. I just have to manually tease out every single argument. In Mongo, I do it with a regex query. With T-SQL, it might look a little different, or you might have a text search implemented. So this is looking like a lot of work for no good reason. It looks like we're going backwards. All those many endpoints that you're used to setting up, it looks like was never that hard. It looks like we're doing a lot of work for no reason. And of course, you don't just want to match on title. Every single one of these fields in your types are all going to need filters. I don't even have enough room to show you the code in the resolver, but you can sort of take a look. You can sort of imagine what it would look like if we went that way. And there's the, I'll let him finish. Okay, so it's very manual right now. It's kind of painful. Do we really have to do all that work? Remember I said it's a primitive, and one of the what makes it a primitive is that it's really easy to build on. So let's take a closer look at the code I showed you. So we had our type, and each property in our type, in order to query on it usefully, we want to sort of blast that into a whole bunch of variants in our query. We want to turn each property into a bunch of filters on our query. And then, of course, they need to get implemented. And again, this is Mongo specific. If it was T-SQL, it would be a slightly different abstraction. This is really, really repetitive. And so you might be thinking, well, I'll write some helper methods to do this. Or maybe you think, hey, why don't I just write up some code where I declare the metadata of my model, of my object models, and I just spit out my type in GraphQL, and I spit out these queries, and I spit out these resolvers, and I just sort of auto-generate that by implementing some metadata. And you could do that. You could absolutely do that. Or, and here's one of my favorite Simpsons memes, GraphQL is super, super popular. So whatever you're thinking you want to do, there's a good chance someone's already done it. If you haven't seen Awesome GraphQL, take a look. Just Google Awesome GraphQL, you'll find it. It's just a huge list of every or many GraphQL libraries that people have made. This is about a third of the JavaScript list. Any language you can think of has some GraphQL implementations pretty much. To give you an idea, the language Clojure, that Lisp language on the JVM, it has 3 GraphQL items on there, and even Haskell has one. Yes, that Haskell has a GraphQL library on it. So whatever you're trying to do, it may be done for you. And you can go even further with this. There's this really cool company called GraphQL, and Jesse mentioned it in his slides last year. But it's GraphQL plus a backend as a service. So you take that metadata, you tell GraphQL, hey, here's some metadata about the types that I want to create and how they relate and what properties they have. And it will not only create you a GraphQL API, but it'll actually create your entire database for you. So it just spits out a database with a GraphQL API on the front end, which is really cool. But doing it yourself actually isn't that hard. I've done it. Here's my little Mongo GraphQL library. You input your metadata about your objects, and it spits out all that stuff that I just said, plus more. I haven't really talked about mutations, but you don't just want to query your objects. You want to update them. You want to delete them. You want to add new ones. It generates all that for you, and I can tell you it really wasn't that hard. It's a little time-consuming, but it's nothing difficult about it. You're just sort of setting up some mappings, which is this next slide. So here's a few words just to sort of sum up what I've said so far, just to sort of tie it together. One of the big benefits of GraphQL to me is that by representing all our queries and mutations in a rich, standardized query language, our data layer becomes nothing more than a thin mapping between these operations and our back end. So we don't have to make a whole bunch of dumb endpoints. We can create a mapping from one smart endpoint into our back end. So there's likely some things that you're wondering about. I threw a few slides in here to hopefully go over that. You may be wondering about authentication. So in real life, you're not just going to dump the whole database out. You only want to dump the results that belongs to that user. So the resolver that I showed you before, I showed you these. I said we talk about these arguments, these function arguments later. Args I already showed you. That's just whatever arguments the user passes to the query. This context here, by default, that's the request object from Express. So that's going to have your user's authentication in it. And you could just sort of pull it out right here and modify your queries to factor that in. But really, you're going to want to plug it into some sort of cross-cutting middleware. Whatever you're using to generate all this stuff is probably going to have some sort of middleware to add that cross-cutting, those cross-cutting concerns. Here's a little code sample. This is just code from my, that I'm using with my GraphQL utility. Mine supports some middleware. You can export a class and connect it to a type. And then I give you all these hooks. I say, hey, you can run this method if you want before any query does anything, in which I say, I don't really care what user ID you sent over. I'm just going to manually set it to who you're actually logged in as. Before you go updating an object, I'm going to make sure we only match that object if you are the owner of it, and so on. this slide has nothing to do with GraphQL. This is just one possible way you might plug in some middleware into whatever you're using GraphQL with. I mentioned you just select what you need, but if you were paying close attention to some of those resolvers, you may have noticed I'm just dumping the entire records from the database. How do you tell what the user is actually looking for? So this fourth and last argument is the abstract syntax tree of your query. So when the user runs a query, this has a whole ton of information on everything that the user asked for. All the results, every field inside of every result. Just a quick slide, just to give you some sort of idea what it's like. The AST has some field nodes. You find the field node you want. It has a selection set with selections in it. And then each item in there may have its own selection set because it's, nested data. Don't worry about that. That's just how the AST works. If you go messing with that, you can explore it. What if I need to select data from multiple tables? So even with Mongo, you're not always going to store everything in the same table. You're still going to normalize your data sometimes with Mongo. What if we have some type with a foreign key in it? Let's say this address ID is an array of integers. Here's a non-string type. And it relates to a foreign key. And it's going to pull back some addresses. So just note this property name, its addresses, all lowercase. The name and typing, the name and spelling will be important. So here's our query. I'm just hard coding some results. Here's that all people query from before. That is, well, anyway, here's an all people query. And it's returning results. But what about the addresses? GraphQL's got a really neat feature whereby you can add another entry to your resolver and name it after your type. So say I've got this person type from before, person. If I add an object in my resolver of the same name, I can throw a method in there. And if I match that method with one of the properties, GraphQL will call this method and give me a chance to just load those addresses up. And let's look at how that works real quick. So you got your results, returning 3 objects, Adam, Bob, and Laura. It's going to come up here, and it's going to call this method, and it's going to pass, instead of root, it's going to pass the Adam object, and I return the addresses for that person. It'll call it again for Bob, and it'll call it again for Laura. Okay, T-shirt, how many queries is that? And don't tell me 4, but like how many queries was run? So I ran the query to get my main results. And then for Adam, Bob, and Laura, so if I have n results, how many total queries am I going to run? Anybody? N plus 1. Yeah, I think you said it. That's enough for a T-shirt. That's not good. Oh, So again, I'm not trying to trash on GraphQL. This is really convenient, and it's really cool, and it seems like it's a bad perf hit. But again, that huge ecosystem out there for GraphQL, there's this really cool package called Data Loader. It's written by the Facebook people, also some of the same people on the GraphQL team, Lee Bryan, some other people. It's really neat. It solves this problem in a really, really simple, subtle way, which is really interesting. So we can create a new data loader, and then here's the key right here. We say, hey, when you give me an array of keys, it's an array of keys, I want you to return back all the users associated with those keys. And if you're into functional programming, you could have just eliminated that and eliminated that, do point-free programming and just pass only that. But I want to show you what's really happening. This method is going to be passed an array of keys, and we'll call that and pass that array in there. And then the way it works is we just load our stuff naively as we want. So we can say userloader.load1, userloader.load2, and then when the event loop turns, this batch method gets called. And then data loader will go under the covers, and it will sort out the results on who goes where. You have to return the results in the same order as the keys and whatnot. So it gives you the ability to do really convenient things like this without getting hit on perf. All right, deep breath. Whew. I hope I didn't overwhelm you. I hope I gave you some high-level stuff to just sort of show you what GraphQL looks like on the server. It's all downhill from here. The rest of the slides are real fun for the JavaScript group. Let's see what playing with some client-side JavaScript toys looks like. So let's just assume you've got a GraphQL endpoint and it works. You may have used GraphQL. You may have some back-end people on your team and they just did it and it works and it's up and running. How do we use it on the client? This is a JavaScript group, so we should do some client-side JavaScript stuff. You can absolutely make GraphQL requests with fetch. You can say fetch, go to your GraphQL address, whatever you set up, and then pass a string with your query, and that will totally work. There's only one reason I can think of why you would want to do that, and that's because it will use HTTP GET. All of the toys that I'm going to show you tend to use POST, and so you can't cache those results with a service worker. And that's important to me. If it's not important to you, then you probably would have no reason to ever use fetch. I've got some slides showing this. They're commented out because they're just too much code and they didn't add any value, but if you're curious, you can pull these slides down, and right after this one, there's some commented out slides. Oh, and by the way, this was made with Spectacle, so every slide here is just React components, so it should be pretty easy to look through. So you could use fetch, or here's the third and final Homer Simpson meme. Here's one example. Here's one tool. The GraphQL ecosystem is really, really deep and wide, and no matter what you want to do, it probably exists. We have this GraphQL request package out on NPM. We can NPM install it, and then we can import this request from it. And so we say, hey, const query equals. The backticks are just strings. They're template literals, which are strings in JavaScript. Little bit of new syntax here. This is just a variable. Don't worry about that. And this means it's required. Don't worry about that. Here's your query. So I'm going to run this movie query. And I'm going to say, hey, pass as the title whatever the title variable is. And then, hey, a variable object. And I can have a title. And then I just say request. There's my address, whatever that is. Pass it to query, pass it to variables. And then it'll of course return a promise, and I can .then on it. Pretty convenient. I could go through this all day. There's tons and tons of libraries that do this sort of thing, but let's sort of jump to the good stuff here. Apollo. This is some of the most impressive activity in the GraphQL area. These guys are incredible. What they've done is really cool, and they're just getting started. I mean, if you've been following them, their latest thing is they're making a state manager. They're going to try and build their own Redux and tie it into GraphQL. Really cool stuff. Here's just a taste. So, any React folks in here? React developers? Cool. So you may be thinking, hey, this structured query language, I can take advantage of that on the client. What if I had a React component and I want it to be tied to a GraphQL query? You may be thinking, okay, component did mount. I'm going to set some state. Well, I'll have some initial state. Loading is true. Component did mount. I'm going to run my query, and then there'll be some callback. And then, okay, I got my data. I'll set state to loading false, and then I'll pass my data down. That's really automatable. It's going to be the same pattern every time. And you may think, well, I can make a higher order component to sort of do that for me. I'll make a higher order component. I'll declare what the GraphQL query is, and I'll just roll it. They did it for you. This is some of their older stuff. This is from the Apollo React package. And so here's how it works. You have some component, class profile extends component. That's a React component. And I'm going to declare my GraphQL query right here. It's just a string. I'm passing it through that tag. Don't worry about that. And then I'm going to wrap this profile component to actually have my data. So I'm going to say const profile with data equals, and I'm going to call GraphQL, which is from the React Apollo package. I'm going to call it with my query, and then that's going to return a function. I'm going to call it again with the component. If you're into functional programming, you may like this syntax. I don't like it. I think it's ugly. But they're just function calls, so you can abstract it however you want. If you like this, then use it. Or sometime in the near future, we may have something like this, where this is a great candidate, in my opinion, for decorators. So this isn't real. Don't try to do this. But hypothetically, React Apollo could export some sort of decorator version of this, where you just slap this decorator on, and you throw the query right there, and I just throw it on top of my component, and that just works. There's one objective disadvantage of this. Can anybody, for a t-shirt, anybody? That's true, but even if it was, you do lose one thing. Testing, right? So one advantage of this is you have your raw component that you can just manually inject data into, whereas with this one, it's going to come preloaded with your GraphQL stuff. And yeah, if you have followed JavaScript well and you've messed around with decorators, you may be thinking that, hey, I can just do this now. I'm just going to take that GraphQL method and I'm going to just use it as is as a decorator. That'll work, but it'll break soon because that language proposal changed quite a bit. So it's going to break as soon as Babel 7 supports decorators. Any questions? Yes?
Yeah, I just want to add though, you're probably writing JavaScript with your Maverick Renegade already, and your loose cannon to look at you. Just use those decorators, man. Just do them. Adam, do you use decorators?
All the time.
Dude, me too, bro.
Do I what?
It's not standard.
Oh, yeah. No, I don't care about this. I'm just saying, if you do decide to use them, just realize it'll break. But I'm okay with that. So just know that. Don't come yell at me that it broke in 2 months.
Don't be afraid that they're not standard.
They should be stage 3 in March, from what I hear, hopefully. All right, resources. Let's say I've convinced you that GraphQL is cool and you want to learn more. Where should you go? This book, Full Stack React, you may not have ever heard of it, but it's really, really good. It's on Amazon. Don't buy the soft cover. It's like 800 pages. Buy the ebook. Load it on your Kindle. It's got React from top to bottom, introduction to React, covers Redux. It covers every part of the React ecosystem, and there's chapters on GraphQL. It goes up setting up your endpoint on the server, just like I did. It goes over all of this stuff. It's really well written, really high quality. I can't believe it's not more popular. Here's one particular 9-part GraphQL tutorial. Again, you can clone my slides and get this URL at home. It's pretty good. Find this guy on Twitter and follow him and read everything he's ever written on Medium. He's brilliant. He's awesome. This is my personal favorite piece he's written. It's called The Anatomy of a GraphQL Query. I covered most of the important pieces. There's a lot more that I didn't cover. Variables I touched on, fragments. There's so many cool things with GraphQL that just only so much time, and I didn't want to cover too much. All right, that's what I have. I figured there'd be some questions, hopefully. If not, I may have just confused everyone. Are there any questions? Jesse?
Are you working on a project right now that integrates Mongo with GraphQL?
Yeah, like I said, I had a slide on that. I've got a Mongo GraphQL starter project. It's on my GitHub repo. It's the first one on there. Mongo GraphQL starter, if you're curious. If you're into Mongo and you're into GraphQL and you want to set up a GraphQL endpoint over some Mongo database, that may help you do that. Any other questions? It is surprisingly common to have this running alongside REST for legacy reasons. So from what I've heard, people have some REST APIs already, and they just want to use GraphQL, and so they'll just make REST calls from their GraphQL endpoint. Because those resolvers I showed you, they're just JavaScript methods. You do whatever you want, and you return stuff. You make them async methods, and you just, instead of awaiting on a call to your database, you just await some call to a REST endpoint, and then you return them back. So you get all your authentication and logging, all the stuff that's already built into your REST APIs now, except now you can just slap a nicer API on top of it. Yeah, something else? Have you ever worked with linked data? No, I have not.
I just wanted to add to that, if you add GraphQL to your project, you don't lose the endpoints you already have. I mean, I think that was obvious from your talk, but a lot of people are unsure if they should adopt it because that means they have to like turn something off and turn something on, and you don't. It's basically just additive. And my suspicion is that in the future, common services and common APIs will probably offer all the exact same REST endpoints they did, and then also a GraphQL endpoint. People want to use that instead, would be my guess. So, as it grows along.
Yeah, you certainly don't lose anything. I mean, here you go. This is just express middleware, app.use/GraphQL. Now that address will go through GraphQL. None of your other stuff has changed in the least. So you can absolutely run them side by side. Who wrote the standards for GraphQL? Is that what you asked? believe Facebook just owns it. I mean, it's released under MIT license. Don't worry about the patents or anything, but I think it's their project. Have they, Jesse? It's still owned by them, right?
Yeah, it is. And to be clear, Netflix had a very similar standard called Valport that they were working on as well. And the community kind of evaluated them, and everyone was working on the GraphQL. So the problems with REST that this is trying to solve were not just identified by Facebook, they were identified by other people. And since they have released it to the community, it's not just Facebook working on it, it's been sort of it's a community project. I would describe it as very similar in nature to how jQuery was after it acquired adoption for the prototypes were built. So there wasn't a jQuery foundation yet, but there was still a body of people working on it, probably like Lodash or something.
I'm just thinking portability. You write like GraphQL versus had a hosted GraphQL site. How well is that going to carry back to your site and bring it in-house?
If you write some GraphQL on a hosted site and you want to port it, it's just code, right? So if you are coding up a GraphQL endpoint in Node, that'll port however well it can. It's just code. It's just JavaScript methods or .NET methods or Python methods, any language.
Every GraphQL query is a REST post method. So if your language of choice can post against the GraphQL endpoint, and then the query itself is a program, then you can do it. Which means basically anything that can talk over REST can use GraphQL. Now, as far as resolvers and things like that, that's going to be, how easy that is to be into your database of your language, obviously. But the actual spec itself is, this is what a query looks like. You post against the endpoint, you shove the query in there, and then you resolve it, and then it comes back. So it's not locked into JavaScript in any way, shape, or form.
Right now, I'm just thinking of, it seems as though so much of the primitives were generated or written by hand. And there were like a lot of different primitives generators. And I'm worried that there's a lot of different, therefore, standards for primitives.
So there's a lot of primitive generators, like primitives being the GraphQL specific things? Yeah, there's tons. Here's the awesome GraphQL page that I showed you before. I'm going to scroll through it, okay? You can see the scroll bar already.
My point is, I see that as a problem, not a blessing. I mean, that's great that there's so many, but there's so many different ones, each with their own little
Well,
variants sort of thing going.
well, it depends on the language you're using. If you need it in .NET, you'll need to be calling these methods from .NET or JavaScript or Python. Here's the JavaScript alone.
And the GraphQL team that wrote the cloud service, their backend is in Scala, just to kind of give you some idea. So one of the techniques they used in their own backend is they used one of the features of the language, which was reflection, to handle all the resolution layers, right? So the spec is really about what the queries look like and what the expected result is. The implementation is going to be specific to the language, because some languages have strengths that other languages don't have when you implement it. So JavaScript doesn't truly have reflection in the same way that C# or C does. So that's one of the reasons why they like that language. So
It's just a query language that represents.
I guess so, but I didn't get to the specific of this. I was thinking Scaffold, which is like GraphQL with a poster, or I'm sorry, GraphQL is a poster for GraphQL. And I was looking into the question of, can I do a filter on a child property?
Mhm.
And the answer was yes, but their implementation of that was unique to them. That code was not going to transfer over.
Oh yeah, none of it will. You have to design your queries however you want.
My own self-hosted.
There's no.
So I'm going to create a ton of code, but I'm locked to that guy because the syntax is custom generated.
Well, think about all the endpoints you normally have. Right now we have many dumb endpoints. None of that's portable. That's all specific to your application. At least with GraphQL, you have a standardized query language.
That's what I'm saying, that the idea of creating a filter on a child relation is equal to saying less standard. Whereas in GraphQL, it's kind of whatever generated primitive, that either, or you can grab all philosophy is. I'm wondering, but I see now what you're saying, that it's not so far along yet that so many things are blessed yet as the syntax.
Nothing's blessed. You design your queries however you want. So here you go. You don't have to do it this way. None of this is portable. You don't have to make these query arguments. You may make different ones. What GraphQL gives you is a standardized language. How you fill that in is up to you, and that can be done any number of ways.
yes,
But it's no different from how you normally do it. You already have your own application-specific code, and that's not going to be transferable anyway. So you're not really losing anything.
You're right, it's less standardized, it's somewhat more REST.
If you use GraphQL, you're all in. Okay? So if you decide to use Graph, they own your data, they created the database for you, you can't even connect to it directly. So don't take that decision lightly. They own your data. But that's nothing to do with GraphQL. That's just one implementation that's possible with how cool GraphQL is. Anybody else?
What's the advantages of this over OData?
The advantages of this over OData. I was talking about this at Slack at work, and I heard about OData for the first time a few weeks ago when someone said, hey, OData already did this. I don't know. No one really uses OData anymore. So you're not going to have a big, giant GitHub repo of helpers that'll be around to help you out with it. That's my serious answer. I don't even know much about OData. It sounds like Microsoft was ahead of the curve on this one, and they tried to do this, but it didn't catch on for whatever reason. I don't know why, but I don't think there's a really good answer to that question. But